Well, good morning. Uh, this is the hopefully short video of the LaGrange error-bound. We have done um, two earlier approximations for error. One was an actual error where you're actually going to find out how far off the approximation is with a calculator or with your brain. The other one we did was called the alternating series error-bound, and the alternating series error-bound um, works only with alternating series. And to sum it up, it means that the error in the approximation is always less than or equal to the first omitted term. That works for alternating series. Today is Lagrange error bound, and it uses it's designed to find errors in polynomial approximations in non-alternating series. So I picked the one we started with, f of x equals 1 over 1 minus x, which becomes x to the n, as long as your x's are between negative 1 and 1. So for example, here's what the error bound looks like. So the Lagrange error bound says that the error, and let's say we're going to make three terms. So the error after the third term, and I'm going to use 0.1 because it's easy to do, and 0.1 is between negative 1 and positive 1, is written as the function value at 0.1 minus the polynomial approximation at the third degree, also at 0.1. So that absolute value is always going to be the error. If the function's concave up, anyway, we don't need to talk about that. So that error. Now, Lagrange error bound says that the error after the third term at 0.1 is written as and this m you're not going to like, the maximum value of the fourth term over 4 factorial over x to the times 0.1 to the fourth. Now notice, you see the third term, the third degree Taylor polynomial, we go to the n plus first term. So I've got that written in the notes, which you can see, and I'm doing this one specifically for the error after the third term. Now the m thing that nobody likes, I'm going to explain what that is. That m sub 4 is the maximum value of the fourth derivative. Well, that's a lovely derivative. Let's try that again. Of the fourth derivative at x equals 0.1. And honestly, I will never let you decide what it's going to be. I will always tell you the value. Now, the hard part is that I or they will tell you the value in the terms of a table, in terms of a chart, in terms of a function, or it'll just tell you. So I'm going to say the maximum value of the fourth derivative at x equals 0.1. I'm going to tell you that maximum value is 100. I'm picking 100 just like out of the air. I did a little bit of fiddling around. If you can notice on my notes, I'm going to pick 100. So that error after the third term at 0.1 is less than or equal to, so it's less than or equal to the maximum value of the n plus first derivative, which is the fourth derivative, which is 100, over 0.1 factorial. So no. Which is over 4 factorial times 0.1 to the fourth. And that's the error bound. if you're asked to actually come up with a number, it'll be a lot easier than this one, but in this case it would be 100 over 24 times 1/10 to the fourth power 1 over 10,000. And that is the maximum value. That is the error bound. That's called the LaGrange error bound. There are a couple problems when I give them to you that I'm going to ask you to do this. Oddly enough, they just kind of make stuff up. They call 100 over 24 5 because they'll call it 4. So they'll take that 100 over 24 and call it 4. So they'll make it 4 over 10,000. So they'll say, is it less than something? And actually, that's as precise as you get.